Okay, welcome back. So,
Sorry.
so now I have erased where Miss Barnes did her work, and I'm going to show you the distributive property, the distributive method. And you are going to take the first term in the first polynomial, and you're going to multiply it by the 3. X squared times 5x to the 4th is going to be 5x to the 6th. X squared times a negative 3x squared is going to be negative 3x to the 4th. And then x squared times negative 5 is going to be negative 5x squared. Then you take the second term and you're going to multiply it by each of the 3. So 3 times 5x to the 4th is 15x to the 4th. 3 times negative 3x squared is negative 9x squared. And 3 times negative 5 is going to be negative 15. After you've multiplied them out, we combine like terms, like before. And I see I have a negative 3x to the 4th and a 15x to the 4th, so that's one thing I can combine. I also see a negative 5x squared and a negative 9x squared. So you have to find all of your like terms, which we've done before in solving equations. So my final answer, 5x to the 6th, negative 3 and positive 15 is going to be 12x to the 4th. Negative 5, negative 9 is negative 14x squared, and then minus 15. So it's written in standard form with my largest exponent at the beginning, decreasing, and it's the same answer that Miss Barnes got. I'm going to show you.
Okay, guys, for the next couple of examples, we wanted to show you some different ways that they might write a multiplication problem, but it's not two parentheses beside each other. So this particular problem we have x plus 2 squared. And we learned when we first studied exponents that to square something means to multiply it by itself twice. So we can rewrite this as x plus 2 times x plus 2. Now there's something you're going to have to keep in mind. Every year I have students ask me this question, what do I do with this? Squaring something means to multiply it by itself twice. So now you have a multiplication problem. We'll do one of each method for different problems. So I'll do distributive method for this one. So you're going to do x times x, which is x squared. And then x times 2 is 2x. Then you do the bottom. 2 times x is 2x. And 2 times 2 is 4. Combine your like terms. So you know with x squared plus 4x plus 4.
And with example number 5, like Miss Barnes said, if you see that exponent, that is how many times you're going to multiply it. So this is 2x minus 3 times 2x minus 3. I'm going to show you the box method. Since I have a binomial and a binomial, I need a 2 by 2. So I'm going to have 2x and a negative 3 and a 2x and a negative 3. You're going to multiply on the outside and put your answer on the inside. 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. Negative 3 times 2x is negative 6x. And negative 3 times negative 3 is 9. Remember to combine your like terms. They're usually going to be diagonal. And then my final answer is 4x squared minus 12x, because negative 6 plus negative 6, and then plus 9.
Alright, number 6 looks similar, but if you notice, these two have the same signs, 2x minus 3, 2x minus 3. This is x plus 4 and x minus 4. So I'll do the box method for that one. You're going to draw your box. You know it's a 4 by 4. 2 times 2 is 4, so you need 4 boxes. And Ms. Hamlin filled out our columns x plus 4 and then x minus 4, which will make this a negative 4. And then we just multiply the columns and rows. X times x is x squared. X times 4 is 4x. X times negative 4 is going to be negative 4x. And then negative 4 and 4 is negative 16. Then you're going to combine your like terms, which should be in your diagonal. -4 plus +4 actually equals 0, so they cancel out, and all you're left with is x squared minus 16. Now again, you don't have to do the box method or the distributive method for any particular problem. We just didn't want to spend a lot of time going over both methods. You choose which method you like and stick to it.
So an application for the whole reason we are adding, subtracting, multiplying polynomials is here's an application problem, a real world problem. If you have a rectangle, shaded rectangle, and then on the inside a non-shaded, and you're trying to find the area. For example, if we wanted to make a garden, but in the middle of our garden we wanted to put something other than dirt, like a statue or something like that. The idea is, what is the area of the shaded region? So the first thing you have to do is you have to find the area of both of the rectangles, the big rectangle and the small rectangle. I'm going to show you using a box method the big rectangle, and Ms. Barnes is going to show you using the distributive property the small rectangle. So I've already seen, you see the big rectangle, so 2x plus 5 and 3x plus 1. So I've already written out my box method, and I'm going to multiply. I get 6x squared and 2x, 2 times 1 is 2x, 5 times 3x is 15x, and 5 times 1 is 5. Once I get all of that and I combine my like terms, I get 6x squared plus 17x plus 5 for the big rectangle.
Alright, so just remember that she's finding, the reason why she's multiplying is because we're finding the area, and area is length times width. So your length is 2x plus 5, your width is 3x plus 1 for the big, and then I'm going to do length times width, x plus 2 times the width of x for the small. Distribute, x times x is x squared, and then 2 times x is 2x. There's nothing to combine, so that's the area of this small rectangle.
And then to find the area of the shaded region, you are going to subtract the shaded region minus the unshaded region, or the big rectangle minus the small rectangle. So Ms. Barnes is writing the big area, the big rectangle's area, 6x squared plus 17x plus 5 minus the small area. Now we go back to our adding and subtracting polynomial lesson. And so we've shown you a vertical and a horizontal way. Whichever one works best for you, we're just going to do it which works best for us, which is probably a horizontal. So 6x squared, well, first of all, if you have your minus,
you need to distribute that minus to everything over here. So Ms. Barnes preferably just likes to rewrite everything into one big equation. You don't have to do this. So minus times a positive would change that to negative x squared, and then negative times positive would be minus 2x. So I just distributed the negative to everything in that second parenthesis. Now all you have to do is combine your like terms. So 6x squared minus x squared would be 5x squared, and then I have 17x minus 2x, which would be 15x, and then the plus 5 doesn't have anything, so it's just plus 5. So the area of the shaded region is 5x squared plus 15x plus 5.
And we are going to practice more multiplying polynomials in class.